JUnit as a habit, not an afterthought. JUnit basic assertions. Lab 1 overview. JUnit basic assertions. The goal of Lab 1 is to use basic JUnit assertions and to use all of them at least once during the course of Lab 1. There are 17 different assertions supplied by JUnit, so we will use each one of them in order to test the methods of a utility library we are writing. The code for the utility library is available from the course's GitHub account at https://www.github.com/entangolov/GRG001 JUnit as a habit, and alternatively it is available on the course's website as a zipped file. So at this point, at Lab 1 overview, you should already have downloaded everything, configured everything, installed the project, and you should at this point be ready to get started. So once you have gotten the code for the utility library, it is time to write unit tests for it, which we will do now in lab number 1. The following basic assertions will be explored at least once in code for GRG001 JUnit as a habit utility application. Assert equals with overloads, assert not equals with overloads, assert true with overloads, assert false with overloads, assert array equals with overloads, assert null with overloads, assert not null with overloads, assert throws with overloads, assert does not throw with overloads, assert same with overloads, assert not same with overloads, assert lines match with overloads, assert iterable equals with overloads, assert all with overloads, assert timeout with overloads, assert timeout preemptively with overloads, and fail with overloads. Quite a mouthful. Each of these assertions will be used as part of a unit test testing the corresponding method within the GRG001 JUnit as a habit utility library. Each unit test will exercise one assertion and one assertion only. Each unit test names will be named in accordance with the naming conventions found in Appendix D. For readability purposes, each set of unit test methods, testing one method from the codebase, will be put in an inner @nested class. So, good luck, and let's get started on lab number 1. So, as we begin lab 1, let us go to the course's website, which is located at grg001.courses.entangolov.com. Once we're there, let us go to unit test code. Here you can see the 5 test classes we're going to write for the 7 labs. And here you see the objects tests Java class, and here is how it looks for lab 1. So spend a little bit of time to familiarize yourself with the course's website before switching over or starting up the IntelliJ IDEA. Here we see that we have imported from GitHub or downloaded from the course's website the GRG001 JUnit as a habit project. And this project we see contains several classes that comprise the utility library. The objects class, which will be seconded by the objects tests class, the strings class, which will be seconded by the strings tests class, the maths class, which will be seconded by the maths tests class, the collections class, which will be seconded by the collections tests class, and the arrays class, which will be seconded by the arrays tests class. And we also have corresponding exceptions for strings, maths, collections, and arrays. So let's take a look at some of the classes themselves. So here we have the objects class, which has static methods, is null and is not null. Here we have the strings class. Except for strings, I'm going to press Alt 7 so that I can see all the classes in a more convenient structure tab. So we have the toUpper method. We have toUpper method, which is overloaded. We have toLower methods. We have split method. We have concat method. We have replace method. And we have an overloaded replace method. Let's go to the maths class. And here we have lots and lots of methods. The first methods, as you can see, they're private static. These are the methods to deal with the fact that Java doesn't have automatic overflow checking. So we have to provide these methods to make sure that we catch overflows of any kind. They're private. We're not going to concern ourselves with testing them. Among the public ones are sum, subtract, multiply, and they have overloads, divide, power of, quadratic, the quadratic function, hypotenuse, and we have a couple of constants, the e constant and the pi constant. Let us go to the collections class. Here we have several methods which apply to collections and subclasses. Is empty, is not empty, has nulls add, has nulls count, max, min, peaks, and throws. Last but not least is the arrays, and it has identical essentially methods as collections because their two are practically the same. Is empty, is not empty, has nulls add, has nulls count, max, min, peaks, and throws. Alright, having reviewed our utility library, it is time to start writing our tests, and we will start with the objects tests Java class. The first order of business we have to do is we have to create the package under our test folder. So let's right-click on the test folder, go to New, select Package, type tech.getRealGood.util.test. Click OK. So at this point, we are going to test the objects class. And as you can see, it has two methods. It's a very basic class, is null and is not null. So let us go ahead and click on the test package name, go to New and select Java class. And let us type the following: objects tests. Alright, and this class is selected. Let us select everything within this file and delete it. Then what I'm going to do, I'm going to go to grg001.courses.entangoliving.com and I'm going to go to unit test code, objects tests Java lab 1. I'm going to place the cursor in the upper right hand side of the code text box and click copy. Then I'm going to switch back to IntelliJ IDEA and paste the code. Alright, so basically there are several ways in which you can carry on throughout the labs. A, you can copy and paste the code, and in that way obviously you have working code, and you can copy and paste it from grg001.courses.entandgolovin.com. The second way, you can copy and paste the code, but then you will go line by line through the code looking for static methods of the assertions class. And you're going to retype the static methods of the assertions class. There may be one or more per unit test method. And the third and most preferred way is that you type everything by hand and then reference the code that is available from the course's website to see if it is similar, identical, and compiles and tests run and are green. So basically those are the three ways. There are several thousand lines of test code. So my preferred way is the third way, that you do everything by hand. If you cannot do everything by hand owing to the volume of the test code, what you should do is you should utilize method number 2. You can copy and paste it, and then you can retype all of the assertions, keeping a careful eye on the unit test logic. That way at least you will have manual feedback, so to speak, tactile feedback on these methods. And I highly do not recommend number 1, just copy and pasting it and making do with that, because it won't give you much of anything. At the most you will review the code, but are you going to grasp it as well as typing the code or retyping parts of the code? No, you're not. So method 3 is my preferred method, method 2 is an okay method, and method 1 is something I highly do not recommend. Now, let us review the objects tests class structure itself. You will notice first and foremost that it is within the tag.realgood.getRealgood.util.test package. You will notice that moreover it imports a logger from JUnit commands. It also imports the subject matter of our unit tests, at this point the objects class from our utility library. And here it is as well open. Moreover, last but not least, it imports all the static methods of the assertions class, which is the subject matter of lab 1. So you see it has package visibility, and that's perfectly fine for our JUnit runtime. It declares a private static logger. Sometimes we will need to log some output even during our unit tests. It's a good practice to do, a good practice to get into the habit of. Then what we do is a little bit beyond lecture 1 and lab 1, but I'm going to teach this to you anyway. We're going to use an advanced annotation that we cover in lecture 4. It's called nested annotation. And it's applied to an inner class. In our case, we have two inner classes. Class is null and class is not null. So as you probably realized already, we put all the unit tests that we use to test the isNull method of object under class isNull. That way we achieve clarity and we achieve readability. And identically, we also put the methods for the isNotNull method of the objects class that we're testing under the inner class is not null, also achieving readability and clarity. The reason I'm going to start using add nested classes immediately is because that way we can avoid naming collisions as we test our code. So immediately we will kind of package all the unit tests applicable to a method being tested into an inner class. And you cannot do it better than by using the add nested annotation. So also we're going to cover one annotation from lecture 2, basic JUnit annotations, add test annotation. So if you can see, the class objects tests has no means of imparting to the JUnit runtime that it's a unit test class. And the only way to impart to the JUnit runtime that it contains unit tests is to annotate a method of this class with the add test annotation. So in that way, we must kind of jump ahead and use the add test annotation that we will cover in the next lecture and the next lab more thoroughly. So our inner class null has two methods. And you will notice that these methods are named actually according to a naming convention. There are several types of unit tests that we utilize. There is a common case, there is a corner case, there is a nullable case, there is an exceptional case, and a couple more that we will delve into later. So you can see the naming convention is as follows. The name of the test the name of the method in the objects class we are testing, underscore, the type of case this unit test tests. Then the parameter type for the method we are testing. So in this case, objects.isNull takes an object, and therefore it's an object here. So there can be obviously one or more parameters or zero parameters, and there could be zero or more of parameter type specifications in our unit test method signature. The last type is the return type always. So we know that by this method signature that we are testing a method of the objects class which is called isNull that takes an object parameter and returns a Boolean primitive. And that is indeed the case. If we click on it, it indeed takes an object parameter and returns a Boolean primitive. The next method, we are also testing the isNull method, but we are testing a nullable case. What if one of our parameters that we pass in is null? And that's how we specify that this is null. But remember, if, for example, a method has more than one parameter and only one of them is null, it would be null underscore something, etc. Or, for example, a type underscore null underscore a type, something like that. And again, we are specifying that it returns a Boolean primitive. Now, you're asking, how do we distinguish between a Boolean primitive and a Boolean wrapper object, for example? Well, we would do it like this. If it were returning a wrapper objects, we would do that it returns a Boolean object. All right, and indeed, here we have it, that it takes an object which can be null and it returns a primitive Boolean. All right. So let us go to the other inner class that is called isNotNull. And what we're doing here is essentially the same as what we're doing here. We have two unit tests. One of them is testing isNotNull method. We are testing a common case. We are passing in an object, and we are getting back a primitive Boolean. And that is indeed what we are doing here. Alright, and let's see the method signature. And indeed, this method passes in an object and gets back a Boolean primitive. The second unit test method of this inner class is also called isNotNull, and it tests obviously the same method, but it takes a nullable condition and it passes a null in and it gets a Boolean back. And you can see from our invocation, we invoke it in exactly the same way, except the object reference points to null. Alright, so having kind of gotten through the structure of the objects test class, let us now attempt to run this unit tests. We click on, we right click on the test folder and we select run all tests, or we press Ctrl Shift F10. Alright, let's go. And let's see what happens. We are going through our build. Build was successful, and now we get the unit test tab. Yes. So as you can see, we ran all the 4 object tests, unit tests, that in our case are packaged within 2 inner classes. Do you see how convenient it is to kind of read what's going on and how clear it is, how the test class is structured? Alright, so all the 4 tests pass, and we are good to go. So before I wrap up this segment of Lab 1, again, let me reiterate the preferred approach to creating the test class is for you to do it by hand. If it is too cumbersome, you do not have time, etc., it is acceptable to copy and paste, but then go through the code, study the code, find all the static methods of the assertions class, and just retype it, just like this, for example. This is also an acceptable way to go about it. Well, thank you for your attention. So I will leave you now to get this unit of work done. And once you're done, please proceed to the next segment of Lab 1. Good luck. So having completed our objects tests review, we are going to proceed to the next test class, which is going to be strings tests. In fact, let us create this Java class in our test package now. Alright, now let us select everything that's currently in there, let us delete it, let us switch to the project's website, and let us go to unit test code, string tests Java Lab 1. Let's go to the upper right hand corner of the code text box and click on copy, switch back to IntelliJ IDEA and paste the entirety of that code into the strings tests class. And as you can see, there are 857 lines of code, somewhat lesser number of runnable lines of code. but nonetheless there is quite a lot of code. Alright, this is how we are going to parse this class. We are going to go one nested class after another. Remember, each nested class tests exactly one method of the corresponding utility library class. For example, in this case, the toUpperTests method tests public static strings toUpper string s throws strings exception method. Alright, so also as we are going to parse these inner classes, we are going to put particular emphasis on learning about the methods of the assertions class. And mostly we're going to be using assert equals, but we're going to go all over the other methods, and we're going to study what they do, and we're going to get that knowledge and that expertise. Alright, so before we proceed to the next video clip, we will dedicate one video clip to each nested class so that it is easier for you to go back and forth to focus on a particular inner class, etc. It's just a better way to go about it for your sake. So let's go now to the next video clip in which we will explore a nested class toUpperTests. Good luck. What we are doing now, having explored the objects tests test class, we are going to proceed to the strings and strings tests test class, and we are going to start exploring one by one the static methods of the assertions class. So let's open the strings class, and let us open the strings test class. And what we're going to do, we're going to right now explore in this snippet the nested class toUpperTests, which, if you recall, we're using to test this method. Public static string toUpper string s throws strings exception. Alright, so we are going to have several methods within the toUpperTests class. In fact, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 methods. Let's go to the first method. And basically we are testing that we can pass a string that is properly capitalized, hello world, and we can invoke the method toUpper of the strings class from our library. And then what we're doing, we're invoking the assertions.assertEquals class. And the first variable that we're going to pass in is what we are expecting. And the second variable is what we are actually getting. So basically, the assertEquals method is the method you're going to find yourself using most frequently in the assertions class, even though it has lots and lots and lots and lots of other methods. But about 95% of what you need to do can be handled using the assertEquals method. Because after all, you're interested in invoking a method or a series of methods and, getting the result that you expect. Alright, we are going to go to the next test method, which is called void toUpper underscore common underscore string underscore string underscore underscore 1. And a few unit test methods that are sprinkled among the test classes are rather contrived, and they could be done away with, but they allow us to test and explore the usage of several methods of the assertions class that we wouldn't ordinarily use that often. Like I said, you're going to find that you're using assert equals method 95 to 99% actually of the time. So, but however, there is an assert not equals method that we need to show how to use. And what we're doing, we're properly capitalizing this string, hello world. We're putting it to the uppercase, so it should be hello world in all uppercases, like here. And then we're asserting that our properly capitalized hello world is not equal to fully capitalized hello world. All right, then we're going to the, so we have seen the assert equals and assert not equals static methods for the assertions class. Let's go to the other method. And here I am doing the same, except I'm using the assert true method of the assertions class. And basically I'm doing the same thing. I'm making a properly capitalized string. I'm capitalizing all of it, so it should be hello world all capitalized. And then I'm saying that the properly capitalized one is not equal to the all capitalized one, which is obviously the case. All right. So, and this is what I would like you to do if you're not typing all of it. This is what I would like you to do if you're not typing all of it. Because you must type something in order for you to get basically some understanding of how to do it. Just retype it. And if you retype it, you will memorize how to type the API. Right. Let's go to assert not equals and do the same. The idea is we at least must type something to retain it. Let's do assert true as well. All right, let's go to the next unit test. And here I'm using the assert false assertion method. So I'm doing exactly the same thing. I'm properly capitalizing the string. I'm putting it all to uppercase. And then I'm saying that they're not equal. So assert false is equals result. Right, let's retype it. And that's exactly what it does. It asserts that the Boolean which comes out from the evaluation of this expression is false. Let us go to the next method. And here I am doing the assert not null method. So basically, whatever comes out from the result of a variable or an expression should not be null. And I am again properly capitalizing it. I'm putting it all in uppercase, and I'm saying that the result variable is not null. And as a rule of thumb, I am writing my method so that it never returns null. And it was very hard for me to think how to use the complement of the assert not null method that is assert null. And I wasn't able, to be honest with you, that's the only method of the assertions class that I wasn't able to stick anywhere. It's just not used within this unit tests. So the only thing that's used is assert not null. All right, let's retype it. And let's continue to the other one. Here we have something slightly different. So we want to assure ourselves that the method strings.toUpper does not throw any exceptions, that it completes successfully. So again, I'm properly capitalizing the string s, and here I'm calling a lambda. This is the lambda syntax. A lambda is a piece of behavior evaluated not at the time you pass it in, but at the time it runs. So basically it says that this code throws no exception. And that's exactly what it means. And you could have a one-line lambda, or you can have multiple-line lambda. What you're saying is that whatever this lambda evaluates does not throw an exception. So let's do this. Got our lambda syntax. Alright, there we have it. Alright, let's go to the next. Oh, this is the lambda, okay. Let's go to the next. And here we have a slightly different case. Basically, we have a nullable case, so that throws an exception. So it's toUpper underscore nullable underscore null underscore string exception. And here what I do, instead of creating a string, I set it to refer to the special null value. And then I'm doing that assertions method called assert throws. And I'm specifying what exception I'm expecting. And I am again specifying the lambda as in the previous example. So, and what this method means, assert throws, is that once you run this lambda, it must throw the strings exception for this assertions to pass. Right, let's retype it. And apologies for my typing, because I'm recording it. Usually it types smoothly, but because I'm recording it and the recording process itself is taking CPU cycles, sometimes it gets so with a lag and I don't really see what I'm typing. All right. All right. And this shall be our line. So at this point, we have covered the following static methods of the assertions class. assert equals, assert not equals, assert true, assert false, assert not null, and it has the complement assert null, but there is no method within this library that throws that returns a null, basically. So I didn't find a place where to put it. But keep in mind there is an assert null as well. Alright, assert does not throw, which basically means that whatever the lambda code evaluates to, while evaluating, it does not throw any exception. Okay, that's our lambda. Assert throws, which basically means that while whatever lambda evaluates to actually will throw our expected exception. And I apologize, I accidentally deleted this line, which is extremely important if you want our code to compile. Alright, let's go on. There are a couple more methods. ToUpper underscore empty underscore string just basically tests what happens when we pass an empty string within our ToUpper method. And what should happen is that it should return an empty string according to our requirements. And that's what it does. And as you can see, I've reverted back to using the assert equals method because for 95 to 99% of the use cases of the unit tests, you're going to have this as the most perfect choice to use. Alright, and last but not least, we are going to have the exceptional circumstance when we pass a null string in there, and we are going to have a strings exception. If you take a look at one of our previous codes, we're essentially doing the same thing, but we are calling it a little bit differently. So we have two identical methods, and that is just to demonstrate our naming convention, because when we have a basically special case, when we pass in a null, we can either name it ToUpper underscore nullable underscore null underscore string exception, or we can name it ToUpper underscore exceptional underscore string exception. So it's up to us what to do. These two methods are totally identical line by line, and they use the assert throws method. So in the microcosm of these 9 methods that we have seen, you see that we are most likely to use two static methods of the assertions class, which are assert equals and assert throws. The rest are nice to have. There are a couple which save us some lines of code, like assert lines equal for comparing lists of strings to lists of strings. But by and large, 99% of our testing is going to be assert equals, assert throws. So what I'm going to do now, just for pro forma case, I assure you they pass, but I'm going to right click on this image against the nested class ToUpper tests. I'm going to select run string tests $ ToUpper tests. So $ means the inner class. Alright, let's go. And let's see what happens. It will proceed to build it first, and then it will give us the tab which will show us whether our tests pass. The very first time you run something in IntelliJ IDEA, it takes a little bit of time to do. Okay, they all pass, wonderful. Now, because we want to complete everything, even though we've seen an instance of these types of methods already, what I'm going to do is I'm going to retype these last two methods, static methods of the assertions class. So that you get the tactile input that you are not likely to forget as easily as audio or visual input. So very important. Just like during the lectures, I always asked you to write stuff down. So is during the labs. I'm always going to ask you to type things out. And ideally, of course, you would type out the entire test class. However, if not, at the very minimum, you absolutely must, and I implore you not to skip on it, you absolutely must type out the very relevant parts of unit tests. All right, next we are going to proceed to testing an overloaded method, also called toUpper, and that's going to be in the next clip. Thank you for your attention. So next we're going to take a look at the overloaded toUpper method of the strings class. Right now, in the past clip, what we did, we took a look at this method, and now we're going to take a look at this method, which takes a list of strings and returns a list of strings. So you might have a page of text that you want to convert to uppercase line by line, and that's what you would use this for. Okay, let us go to strings tests. We are going to see a few more of methods of the assertions class that we can use to write unit tests. And the first such method is going to be within the toUpper tests __1 class, within the toUpper _ common _ string list unit test method, and the assertions class static method that we going to take a look at is called assert lines match, where we pass in a list of strings and a list of strings. All right. Let us decompile it. You can see that there are usually lots of overloads of these methods. For example, assert lines match, there are 3 methods in total. One which takes a list of strings, the list of strings, one which takes a list of strings and provides a message if it fails, one which takes a list of strings, and provides a functional interface called supplier type string message supplier. It's nothing more than a lambda with a message you want returned if it fails. It's slightly more flexible than just passing a message in here, because remember, lambdas are evaluated at the time they're run, not at the time they're passed in, and the variable is captured at the time the lambda is run, so its value may be different than what it is at the time you pass it in. Alright, so let us go away from the assertions class for now, and let's go back to the strings tests.java. The assertions class that we just saw, I think it was decompiled on the fly by IntelliJ IDEA, but it could also have come from the source for JUnit 5 if you also downloaded a source. And we're going to refer to the Assertions class. Let's actually go back there one more time. To Assertions class from time to time in order to basically take a look at some overloads. For example, where is it? The assert equals method that we have taken a look at has this many overloads, and it goes on and on and on and on for different data types with messages, with functional interfaces, instead of just messages, etc., etc. Lots and lots of overloads that you can see. For all cases that you might encounter in your testing practice. And again, this is the method you will use most frequently, but not always so. Not always will you use it, because, for example, for collections, there are methods that are more suitable and save you some time. All right, we're still going over the overloads of the assert equals method, and we could go on and on for some time, just to show you that this API is quite extensive and covers all the types you're likely to need. And of course, here is the most flexible method because it has objects. All right, there we go. All right, let us go back to strings tests. So our first unit test uses the assert lines match. So we have a list of strings and we have another list of strings. And what we want to do, we want to pass the original list of strings and change it, all the strings in it, to uppercase and get the result. And then we want to compare that the result actually matches this array list. And it does, because after we pass this list within our method, it should produce a list of strings that are all capital letters. All right, let us type it on our own. Assert lines match. Just a second, it's not lines, it's result. Already. Now remember that typing by hand is much better than hearing about or looking at, because when you look at when you hear about, you forget almost immediately if it's a voluminous body of information. When you look at it, you retain some of it and you think you know it, except when you need to use it, you just don't remember what you're doing. And the only way to know how to do something is by doing, and that's exactly what we are doing. All right, so assert lines match, take basically two lists and goes line by line within the lists, making sure that the strings are equal. Let us go to the next use case, test case. And what we're doing here, we are using a very similar assertion method, which is called assert array equals. So we have covered assert lines match, and that's what we're using for strings. And here we are doing assert array equals. I am declaring an array of strings, another array of strings, And the third array of strings is what I get when I pass in basically the first array into the our2upper method. I actually converted to list. Well, some of these examples are a little bit contrived, as you are probably thinking, but they illustrate very well our assertions method, so it's okay. I get the result as the list, I convert it to the array, and I basically tell the JUnit assertions class to make sure that the result, all capitalized hello world members, items of the result, are actually equal to the array you want to compare it to, all the capital letters here. And what it does, it goes one by one, and it uses the equals semantics to compare it, and it actually compares it and produces the true results if the two arrays are equal. And here we can see there are lots and lots of overloads, lots and lots of overloads, lots and lots of overloads. Equals, and that makes sense because there are different types of arrays, arrays of primitive types, arrays of object types, etc. Let's take a look at how many we have here. Lots and lots of overloads. And you will notice the pattern that these methods follow. They take the expected result, they take the actual result, and sometimes they take a string message which is displayed in the case the assertion fails, and sometimes they take a functional interface called supplier of type string, which is a lambda that is evaluated at runtime and displays the method that it pulls it during runtime. Alright, and you can see we have lots and lots of overloads for the assert array equals method. Alright, let us go back to strings.tests. Let us retype so that we memorize in a tactile sense what we need to memorize. So far we have covered assert lines match assertion method and assert array equals assertion method. Let's go on to the next unit test, and here we are going to pass a null value for the list, and we're going to assert that this sort of null value will throw a strings exception once we pass it in. And we have seen the assert throws assertion method. It is one of the two most popular assertion methods, assert equals and the plethora of overloads and assert throws. Right, let us retype it. And of course, as we see more and more of the same types of methods, so my apologies. A little bit of a problem there. Alright, as we see more and more of the same type of assertion methods, feel free to keep typing them. However, you should be confident if you skip typing them that you remember them. All right, there we go. Last time I deleted the null, which I'm not gonna do this time. Let us go to the next unit test. This one we are going to pass an empty list into our method, and according to our requirements, what we should get out of it is an empty list as well. And here we have our venerable assert equals method, because for most situations in unit testing, you want to know what the equality, if it is equal, or what does it throw, basically. So we pass an empty array list, and we get back a empty list. All right, let's type it. And there we have it. And once again, the more you see of the same kind of assertion methods, you can skip it if you want, or you can type it. You will memorize it better. So at least several times you should type it. All right, and the last but not least unit test method of the two upper tests __1 nested class is going to be to upper _ exceptional _ string list _ string exception. So we are passing in an array list, and we are putting a null as an item within that array list, and we are asserting that such an array list passed to our to upper method of the strings class will throw a strings exception, which is exactly what it does if you read the code for the strings class's appropriate method. All right, let's retype it. Now, as we move forward with our lectures, you will discover that lecture number 1 is probably the most time-consuming lecture of the 7, and you will discover that it is the most relevant to 95% or 99% of what you will do in your unit testing as well. So here we typed it. Now, to make sure that all the tests pass, we're going to run this particular nested class. Let's see that all of them pass, and then we'll go on to the next clip. All right, they all pass, and next we're going to explore the nested class to lower tests. Thank you for your attention. I will see you in the next clip. So next nested class on our plate is going to be nested class to lower tests. And the first method, unit test method we're going to write is going to be called a test void to lower _ common _ string _ string. And here, as you can see, we're declaring a string. We're putting it through our method, and then we're doing something that I wouldn't ordinarily do, but I wanted to show you how it's done anyway. We're calling two assertions methods. We are asserting that it's not null, and we're asserting that it equals to something else. Usually I would refactor this unit test, split it into two, but just to show you how it's done. Alright, so the very first few times we see an assertion method, I'm going to write it, and then I'm going to stop doing that, and it will be entirely up to you whether or not you want to do it. Alright. And we're done with this method. You will notice that I enclose all of our methods within a try-catch block, and that I'm invoking the fail method, its overloaded version with the message of what went wrong exactly. So if any part of our code throws an exception, we're gonna fail the method unequivocally. Alright, let's go to the next method, to lower underscore nullable underscore null underscore string exception. And here we are declaring a string reference, but we're making it point to the null value. And then we assert that once we pass the null value to the lower method, it will throw a strings exception. So we've seen assert throws before, obviously, but the very first few times I'm going to retype it anyway. Just so that you get a hang of it, how it's done. Alright, and of course there is a typo, that's why it's red. And now it's all good. Alright. The next method, the next unit test method is void to lower underscore empty underscore string when we pass an empty string to our to lower method, and we are asserting that we're getting an empty string back. So I'm going to retype assert equals a few times, and you should get used to typing assert equals because you will be using it for 95% of the time. Alright, to lower. Apologies for the typos, I'm recording it in the evening time. Alright, last but not least is the void to lower underscore exception underscore strings exception. And obviously, just like before, it is identical to this method, to lower underscore nullable underscore null underscore strings exception. So in our naming conventions, everything is pretty much cut and dry for unit test naming, except sometimes you can substitute nullable case for an exceptional case and vice versa. Right, and it does exactly the same thing as here, but I'm going to retype it anyway. And I'm hoping that you're retyping it in your code as I go along. Alright, and we are done with this inner class to lower tests. Next, we are going to go to test the overloaded to lower method, which takes a list of strings. So thank you for your attention. See you in the next clip. So in this snippet, we are going to explore the nested inner class to lower tests underscore underscore one. And this inner class is is going to contain unit test methods that we're going to use in order to test this toLower method. It's an overloaded method. If you recall, in the previous clip, we explored the toLower method, which took a string and returned a string. And in this clip, we're going to explore the toLower method that takes a list of type string and returns a list of type string. So just a convenience overload. Let us go forward. Our particular emphasis in our clips is to memorize very well the assertions methods of the assertions class. That's what we're going to do. So this method is void toLower underscore common underscore string list underscore string list. And what we're doing, we are creating an array list of strings that we're going to pass to our methods to be modified. We are creating our reference array list. Then we are passing our initial array list to the method. And then we are asserting that the result is equal to our reference array list, which is all lowercase hello world. All right? We're using assert lines match. And what I'm going to do for the first few times that we encounter a certain assertion method, I am going to always write it out. Right? And I highly recommend you do as well, because that will enable you to have tactile memory of what you do. So assert lines match, in our case, will make sure that whatever is returned into this variable has an array of strings that are all lowercase and are all hello world. And in fact, let us just, for the fun of it, let's see if it works properly. Let's do a build. Let's wait. By the way, this build system that IntelliJ IDEA utilizes, you can use Gradle or Maven as well. We use end by default just because we have no need for anything fancier. But on the downside, end is probably the slowest that we could do. All right. So, and the test passed. Right. Let's go on to the next unit test. toLower underscore common underscore string list underscore 1. And here we do the same thing as in the previous method. Exactly the same thing. But we're using something we haven't seen before. We are using assert iterable equals. And assert iterable equals is a assertion method that can be used on collections that implement the iterable interface. And the iterable interface, if you recall, is something that you can use in the special case of the for loop in Java, where you iterate over each element of a collection. So what enables this iteration is the fact that you implement iterable type T interface on a collection. All right, so assert iterable equals just takes two instances of iterable type T interface implementations and compares them. Let us retype it. And in our case, obviously, because we're using a list of type string, we can use either assert lines match or assert iterable equals with the same success. All right. Yeah, press and insert. All right, let's just see that it works as intended. And it does. Wonderful. Let us go to the next one. And here we do the same thing. Initially, up to here, we invoke the same method, but then we're going to use a new assertion method, assert not same. And assert not same basically means that the identity of the objects that we're asserting are not same is different. That is their basically memory address. It doesn't test for equality, it tests for identity. All right, and let us retype it. Already. Just a second. And let's see if it works. And it will work because I tested it before. All right. Let's go on to the next unit test. So far we have seen several assertions methods. Assert lines match, we saw it before, and then a couple of new ones. Assert iterable equals and assert not same. And you will notice that for the last two unit tests, for this and this one, our usage is a little bit contrived. To be honest with you, it is contrived. And that goes back to my saying that assert equals is going to be good for 95% of what you do. And sometimes when you're looking to teach other assertions methods, you have to invent kind of contrived examples that you would not likely to implement in your job. Nonetheless, they very illustratively demonstrate the working of certain assertions methods. Right, let's go to the next one. And here we're going to, it's the same, we're going to declare our the first array and our reference array. Please notice that the first array is already all lowercase. This is also all lowercase, and we're feeding it to the lower method. And we're asserting that they're the same string objects. And they are, because when we declare it at compile time, not at runtime, the JVM will put it all in a strings table, and the same strings will be shared. So they will have the same memory address. This is done for the purposes of efficiency, and that's to be a little bit clever, to be honest with you, and to demonstrate the assert same method working. Let's see that it works. All right, it works. So it asserts, basically assert same means that whatever is expected and whatever is actual point to the same memory address. All right, let's retype it. Here we are able to utilize this due to a clever compiler optimization that the JVM does. But the compiler optimization itself is not part, obviously, of the lecture, of the lab. Just something to make it a little bit more interesting. All right, let's go to the next unit test. And here we are going to do precisely the same, but with arrays. we're going to make our array that we're going to feed to the lower method. We're going to make our reference array. We're going to feed it to our S array to the lower method, converting it into a list in the process. And then we're going to assert that arrays are equal, our reference array is equal to our result list converted to an array here. So assert array equals just basically means that we take an array number 1, an array number 2, and we basically go ahead and compare this array's value by value, element 0 to element 0, element 1 to element 1, etc. Right, let's type it out. Didn't do the right, I put a comma instead of. Right, let's see that it works, and it will. Alright, and we're good there. Let's go to the next one. And here we are basically going to pass a null list. We're going to pass it into our overloaded methods to lower. And we're basically saying that it will throw a strings exception, which it will. Right? We've seen assert throws before. And it is one of the two most important assertion methods that we can utilize, the other being assert equals. Alrighty. What do we need to do? Oh, yes. Right. We typed it. Let us go on to the next one. And here it actually should be string list here, according to the naming convention. What we do here is that we create a list of capacity 0, so it has no strings. We invoke the overloaded to lower method on it, and we should get an empty array list back, which is what we do. Right. Let's run it. I'm going to stop retyping array assert equals at this point. Assert equals method we've retyped quite a few times. If we encounter overloads of assert equals, I will retype it, however, but not if we see it in its most basic form. Last but not least is what we do. We create an array list of capacity 3, and we insert 2 normal strings and 1 null value in it. And then we assert that once we invoke the toLower method on this list, that it will throw a strings exception, what it will do. Right, let's retype it. Let's run it. and it's good to go. Alright, let's now test all the tests within our inner class, just to see that they run okay. Alright, and they do. Okay, in the next clip, we're going to take a look at the split tests inner class. So we're going to run through the split tests inner class, and like I have said several times before, what you're going to see likely is 95% of the time you're going to use the assert equals method, and that's exactly what we are seeing. We're using it several times in this method because we are testing, in fact, what is contained in a list of type string. That's one of the use cases where it's acceptable to use several assert equals methods. What we could have done here, we can refactor it, we can create a reference array, and we can use assert lines match or assert iterable equal or assert array equal. Alright, let's go to the next, and here we're doing the same thing. And here the same, assert equals. Here we are doing assert throws. And here we are doing assert equals. Now, when I seem to be spending just a little bit of time on a unit test method, you're very welcome to stop the course, to retype to study the code if you need to study the code, to retype what you need to retype, and then to resume and to continue. Basically, we have about 300 unit tests as of now written to test this utility library of ours, and I'm not going to burden you with excessive repetitions of what is essentially many unit tests using assert equals methods, and only or assert throws methods, and only a few unit tests of interest that use this more rare assertion methods. That we need to cover all of them. So I'm going to finish this clip. It's a very short clip. And in the next clip, we're going to run through concat tests inner class. Alright, in this clip, we're going to run really quickly through inner class concat tests. Let's go to the first unit test. And basically, what we're doing, we're creating an array of strings. Then we pass it to the concat method of our strings class. And then we assert equal that the result is exactly hello world. So not much there. In the next one, we are doing pretty much the same, except we're not instructing the concat method to trim anything, and so we are checking that it doesn't in fact trim anything, which is what it does. Alright, in the next one, we are doing the same thing, but this time with trimming, and we're checking that it in fact trims. The next one, what we're doing is we are passing in an array of 2 empty strings, and we are checking that in fact we are going to get an empty string as our result, which is what the case is. Alright, the next one, we are doing the same thing, except now we're streaming. Well, it makes no difference. And this is also evaluates to true. Alright, now what we are doing, we are passing in a null list to the concat method, and we are certain that it will throw strings exception, which is what it does. Alright. And we're also using that the variable that we instruct in the method to trim it. So, but in the next one, we are instructing, it's the same as the previous one, but we are instructing not to trim it. Well, it shouldn't make any difference whatsoever. This is a good example when we vary some secondary parameter in order to accomplish higher test code coverage, because if you only test for true, for example, well, there is code within our concat method that is predicated on this value being false, and if we only test for true, then we're going to miss some lines of code. So that's why we have an overloaded, so to speak, unit test method, and we're trying to test all paths through the concat methods code. Of course, we cannot usually test all the paths, or it doesn't make sense to test all the paths all the time. But we should do as much as we can to raise the code coverage metric. That is, that our unit tests test as many lines of code within our method as possible. We need to raise this value as high as it is logical to do so. Alright, so let's see if all the tests pass. And they do, I assure you, because I tested them before. So let's see how it goes. All right. Let's see if it works. And it does. Okay, in the next clip, we are going to check out the replace tests. All right, we are going to check out the replace tests. There are a few. We'll run through them fairly quickly. Because remember, most of them use either assert equals or assert throws. So in this case, we're basically taking a string called hello world. We're taking the O vowel and we're replacing it with the E vowel, and we're trimming any space from the beginning or the end. And we're asserting that the result will be hello world, which is what it is. Alright, in the next unit test, you will notice here also that here, for example, we have package visibility, and here we have a public visibility. Doesn't really matter, but you can forgo the public access modifier, just less typing for you. Alright. So basically here we're again getting the same string, replacing O with is, but not trimming it, and we're getting hello world and then a space at the end, which is what we are doing. And it is again assert equals. Once again, it is up to you whether you want to retype it or not. You know, repetition is an extremely useful tool for memorization, but we have already repeated this particular one quite a few times. And once again, anytime you feel you need more time to study the code or to retype something, feel free to stop the course to to do what you need to do and then to resume the course. Let us go to the next unit test. And here we're basically taking an empty string, replacing its O's with E's, which it doesn't have any. And we are certain that we will get an empty string in return, even if we trim it, which is what we will get. In the next one, we are doing the same thing, except we are not trimming. Well, in this case, it doesn't make any difference. We still should get the empty string back. Next, we are certain that if we pass a null string into our replace method, then what will happen basically is that it will throw an exception. And you see here that there is a little bit of a hiccup. These variables are not used. Instead, I'm just using A and B here. So I can go ahead and delete this one, so it won't make any difference. In the next one, well, let me delete the same thing. We're also passing in the null string, and we're certain that the code will throw a strings exception. Even though we're trimming, makes no difference. We're just kind of upping our test code coverage metric because we are interested in our code with trimming true, with trimming false, because it does exercise different parts of our method. Potentially, we don't know. All right, the next one is a special case. And that's the first time we have seen a special case. And a special case in our case is when the string does not contain the symbol we're trying to replace. That's a special case. We don't have the symbol within the string. We'd like to see how our code behaves. And so once we invoke the replace with trimming or without trimming in the next method, it should still produce the original string of hello world, in this case minus the space, in this case with the space, which is what it will do. All right, and here again, the only difference from the previous one is that we are not trimming our original string and it has a space at the end, and that's what the result should be. All right, let's run all of our tests and see if they pass. And they do. Well, good job, Anton. And I'll see you in the next clip where we're going to finish this strings tests test class with the replace tests __1. So last but not least is the replace tests __1 inner class, which just basically tests an overload of the replace method. This overload is very similar to the one we explored in the previous clip, except it doesn't have the boolean of whether or not to trim the string. It basically by default invokes internally the method without trimming the string with the trim set to false. Alright, so we got our string. We got the vowel O that we want to replace with vowel E. We invoke the replace method, the overloaded one. And we assert that we're going to get hello world with a space, which is what we'll do. Pardon me. The next one is we're doing the same, except we're trying to replace an O with an E in an empty string. Then we're invoking the overloaded replace method, and we should get the empty string back. Last but not least of the last but not least is the nullable case, where we're passing the null string, and we are certain that it throws a strings exception, which is what it will do. Let's try to see what it does. And it passes all the tests. Let's check that all of our tests within our strings tests test class pass. So we'll do one more build and one more unit test run. And all of our 49 tests pass just fine. What we're going to do next, so far we have done objects test class and strings test class, and we're going to see that when we run all the unit tests within our test folder, that they all pass. Let's see. And all of the 53 unit tests that we have so far written pass with flying colors. So next clip we will review basically what assertion methods we have covered so far, and then we will move on to the third test class of the 5 that we are writing, and the third test class will be called maths tests. So thank you for your attention, and please stay tuned for the rehash of which assertion methods we have covered so far. JUnit basic assertions lab 1 rehash 1. So far in lab 1 we have covered the following assertions: assert equals, assert not equals, assert true, assert false, assert not null, assert does not throw, assert throws, assert lines match, assert array equals, assert iterable equals, assert not same, assert same. In the test classes to follow, we will cover the rest of assertions methods from the assertions class, as well as overloads of all the assertions methods. So stay tuned. So in our next clip, we are going to be exploring the maths tests test class, and in order to get that, let's right click on the test package, select new, select Java class, and let's call it maths tests. Alright, it's going to get created. Let's select everything within the class and delete it. Then let us go to the project website, go to unit test code, maths test Java lab 1. Highlight the box, select copy, go back to the IDE, press Ctrl V, and it should get copied to our class. Alright, so now we are ready to get started with our maths tests test class in the next clip. So in this clip, we are going to start on doing the maths tests test class by going over the inner class sum tests, which is going to provide several unit tests for the maths.sum method. So let's go to the first unit test for the sum method, and here we declare an array of longs, and we provide 7 values, and then we assert equals that the sum of those values is going to be equal to 70, which is the case. You are most welcome to retype assert equals and the rest of the line. We've retyped it quite a few times, so I'm going to skip it, and I'm going to go to the next one. All right, here we're going to pass an array of longs. We're getting a long back, and this example is a little bit contrived, but nonetheless useful. You will see here that we are starting with a new assertion method. We haven't seen it before except in the lecture. It is assert timeout. Then we are providing that we are asserting that the timeout will be no more than 1 second. And then we are providing a lambda invoking the sum method on this array. So assert timeout assertion method runs in the same thread as the unit test method, and basically it will succeed if it runs under or equal to 1 second. If it takes more than 1 second, it will fail. Let us retype it because we have not seen this assertion method before. And we are done with this unit test method and with this assertion method. Let us go to the next one. And again, the example is a little bit contrived. It does exactly what the previous two unit tests do, except it uses assert timeout preemptively. And it also says that it will have completed within 1 second. And it also invokes the sum method. The difference between assert timeout and assert timeout preemptively is a very simple but meaningful one. Assert timeout preemptively basically will be spawned in its own thread, and it will execute in its own thread. Okay. Let us retype this assertion method. We have not seen it before in the lab. All right, and we are done. Let us go to the next unit test method. So the next unit test method is going to test the very fact that the actual value that we're passing into the sum method is not an array of longs, but a var arg of longs. So we're going to declare just one long. We're going to pass it into the sum value, and we're going to assert that it will be equal to itself, which it must be. And it's using assert equals. You're very welcome to write it out if you wish. We're going to go to the next unit test method, testing the sum class. And this one just basically declares two long values, which both are max values, so it must create an arithmetic overflow. And we're just testing that our method must throw, in this case, a math exception, which it will because our arithmetic overflow logic is very good. So assert throws, we've seen it before. I'm not going to retype it. This is an interesting exceptional condition, and you're very welcome to study it further. Our next method is we are going to pass two min values, and we are going to sum two min values. And what we're asserting is that it will throw a mass exception, which it must. And it's the same, except of the max value, it's you're passing the min value. And just to show you that it works properly, I'm gonna run that one and this one. All right. And takes an inordinate amount of time to build, but for our purposes it is sufficient. We could be using Maven or Gradle, would be faster. All right, that works. And this one as well. Just an interesting corner case that we call exceptional. It must throw an exception. Let us go to the next unit test. It's a special case. We are creating an array of longs which are all 0. And we are asserting that the sum is equal to 0, which it must be. And we're using assert equals. You're very welcome to retype it. And we're going to go to the next unit test. Here we are declaring an array of long values and are pointing it to null value, and then we are asserting that the sum method of the mass class will throw a mass exception if we disrespect it by passing a null value into the method. Pardon my joke. So, and that is what it will do. Let us try to run all of these tests now to see that they will pass. All right, excellent. So we have seen, just to reiterate, in this inner class testing the sum method of the methods class, two new assertion methods: assert timeout and assert timeout preemptively. All right, so good luck. In the next clip, we are going to take a look at the overloaded sum method of the mass class. In the next clip, we are going to refer to an overload of the sum method of the mass class. So this sum method basically takes a var arg of doubles. We can pass an array, we can pass a scalar value, if you will, literal value. So the first unit test is going to be, we are declaring an array of doubles, we are passing the array of doubles into our sum method, and we are declaring that it will be equal to 70, which it will be. So the conversion is automatic, you will notice here, and you see what we are testing: a var arg of doubles returning a double. So to save a little bit of typing, we're just passing in non-double values, which are automatically converted into double values by the compiler. All right, so in this case, we are invoking assert equals. We've seen it numerous times before. In fact, it will be 95% of the assertion method that you will call. So you're welcome to retype it. We're going to go to the next one, to the next unit test. And here we are doing the same. We're declaring an array of double values. However, here we are doing something else. We are calling an assertion method called assert all that takes lambdas, which are a personification of the executable interface. And this lambdas basically must run without throwing any exceptions all of them for the assert all method to pass. So for example, if our first lambda throws an exception, but in our second lambda does not throw an exception, the assert all method will fail. If our first lambda does not throw an exception, but our second lambda throws an exception, our assert method will fail. If both of them throw exceptions, then it will fail as well. If none of them throw an exception, then and only then will the assert method pass. Alright, and consequently, then and only then will our unit test pass. So I'm going to retype the assert all. This is an assertion method we have not seen before in the lab. Assert all. Let's do it for readability like this. Alright, and we are done. Now all these two methods must, as we can see, run successfully. The result of the first one will be a double equal to 70.0. The result of the second one will be a double equal to 80.0. Let's just run it to demonstrate that the assert all assertion method performs as intended. You'll have to wait for the end to do its thing. And now it should pass. Excellent. Alright, having demonstrated the workings of the assertion method assert all, let us now go to the next unit test. And here basically we are using a literal double value of 10. We are passing this literal double value to a parameter that expects a var arc of doubles, and we are asserting it will be equal to 10, which it will be. And we're using the assert equals method, which we have seen multiple times before, so I'm going to skip it. Next one, we are doing pretty much the same thing as we did with longs. We're passing two double max values, and we are asserting that this will cause a arithmetic overflow, which it will. We're using assert throws. We've seen it multiple times before. You're welcome to retype it. I'm going to go to the next unit test, and here you can see that we're using negative double max value, because double mean value, strangely enough, is the value closest to 0 that we can obtain. It's not a negative value. That's how Java handles it. C# handles it differently, if I remember correctly. So in order to test what we want to test, we have to use two negative double max values. And we are certain that it will cause a math exception, which it must. And we are using assert throws. Let us go to the next one. Here we are testing a special case of all zeros, just like we did with longs. So we are creating an array of doubles, and all the members of the array are zeros, and we are asserting equals that it's going to equal to 0, which it must. Okay, last but not least for this overloaded method is we are setting a array of doubles to null, and we are passing basically a null value into the overloaded method. And what it will do, it will throw a mass exception. Alright, now let us check that all the tests pass. And then we will go on to the next method that we are testing. Alright, they all pass. Okay, thank you for your attention. Next is subtract tests. In this clip, we are going to talk about the subtract tests inner class, testing the maths.subtract method. So the first unit test is going to be subtract common long array long, and here we are passing an array of 7 tens, rather 6 tens. We are subtracting it from the value of 10, and we are stating that it will equal to minus 15. We are using the proverbial assert equals method, and it should work fine. The next one, we are passing a literal value, and we are subtracting it from a literal value, and we assert that the assert equals invocation should compare it against 0, which is what it should do. Again, it uses assert equals, which you will use for 95% of your unit testing. In the next one, we are basically subtracting mean value and another mean value from 0. And that obviously should throw a mass exception, because it will cause an arithmetic overflow. And we are using assert throws, and in the end we will see that it is exactly what it does. Alright, in this case it's the same as the previous one, except we are subtracting max value from it, and it again will cause an arithmetic overflow, and we are certain that a maths exception will be thrown, which it will be. In the next unit test, we are passing a null value for a long array, and we are certain that a mass exception will be thrown, which it will be. And in the special case, we're passing an array of longs, which are all zeros. We're subtracting it from 0, and we are expecting 0. We're using assert equals, and that's exactly what will happen. Let's run all of these unit tests, and let's see that everything works fine. Alright, and it does. So in the next clip, we'll take a look at the mass.subtract overload. Next, we're going to take a look at the overloaded mass.subtract method, which takes a var of doubles. And we're going to take a look at the 6 unit tests that we'll be using to test it. At this point, unless we are going to encounter a new assertion method, I'm going to literally just skim over a unit test, because there are roughly, I think, around 300 unit tests, and it would be cruel and unusual punishment to make you spend any significant amount of time on all of them. So for this unit tests, what we have here, we have the same set of unit tests that we have for the long var arg, And we're mostly using assert equals for the first one, assert equals for the second one, assert throws for the third one, assert throws for the fourth one, assert throws for the fifth one, and assert equals for the sixth one. Let's make sure they'll pass. And they do. So the next one is going to be unit tests to test the multiply method of the mass class. And there are 6 unit tests. The first one is using assert equals. The second one is using assert equals. The third one is using assert throws. The fourth one is using assert throws. Fifth one is using assert throws. And sixth one is using assert equals. The first one is testing a common condition. The second one is testing a common condition. The third one is testing an exceptional condition. The fourth one is testing an exceptional condition. The fifth one is testing a nullable condition, which is a type of exceptional condition. And the sixth one is testing a special case. Alright, let's go forward to the overloaded multiply method, which takes a double and a vararch of doubles. There are 6 unit tests. For the first one, we are using assert equals for the common case. The second is a common case, we are using assert equals. The third one is an exceptional case, we're using assert throws. The fourth one is an exceptional case, we're using assert throws. The fifth one is a nullable case, we're using assert throws. And the sixth and last one is a special case, and we're using assert equals. Alright, in the next clip, we are going to take a look at divide tests, power of tests, etc. In this clip, we're going to take a look at the divide tests inner class, which will test our divide method of the mass class. There are 6 unit tests. The first one tests a common condition and it uses assert equals. The second one is using a common condition, it uses assert equals. The third one is an exceptional condition, it uses assert throws. The fourth one is an exceptional condition, it uses assert throws. The fifth one is a nullable condition, it uses assert throws. And the sixth one is a special condition of all zeros, it uses assert throws. So let us, because you cannot divide by 0, let us now test that all of them run fine. And they do. Let's go next to the power of tests. There are 6 which tests. There are 3 power of methods within the mass class. We are going to test the first power of test. There are 6 unit tests that we're going to do that with. And the first power of test takes a long and a vararch of longs. It's a common case, and we're using assert equals. The second one is also a common case, and we're also using assert equals. The third one is a nullable case, and we're using assert throws. The fourth one is an exceptional case, and we're using assert throws. The fifth one is an exceptional case, and we're using assert throws. The sixth and last one is a special case, and we're using assert equals. So at any time, if you feel like it, feel free to stop the presentation, to spend more time studying the code if you need to, or you can study this code after the clip has run its course. It's up to you. So the next method we're going to test by using the inner class power of tests1 is maths.powerof, which takes a double and a var of longs. There are 6 unit tests. The first one tests a common case and it uses assert equals. The second one uses a common case and it uses assert equals. The third one is a nullable case and it's using assert throws. The fourth one is an exceptional case and it uses assert throws. The fifth one is an exceptional case and it uses assert throws. And the sixth and last one is a special case and it uses assert equals. The third and last overloaded method of maths class is powerof, which takes a double and a var of doubles. It has 6 unit tests. In the first one, it's a common case and it uses assert equals. The second one is a common case, it uses assert equals. The third one is a nullable case, it uses assert throws. The fourth one is an exceptional case and it uses assert throws. The fifth one is an exceptional case and it uses assert throws. And the sixth and last one is a special case and it uses assert equals. Before we finish the script, let's run each of those inner classes. Each inner class represents the battery of unit tests testing one method of the maths class. This one passes. Let's try this one. This one passes. And this one. What does this one do? And this one passes as well. All right, it is time to complete the clip. In the next clip, we're going to take a look at quadratic and hypotenuse tests. So I'll see you in the next clip. So next we're going to take the quadratic tests, which test the maths.quadratic method. And we have 7 unit tests. The first one is a common case and it uses the assert equals method. Our list, which is the result of the invocation of the maths.quadratic method, is a list of size 2, so it's okay to use assert equals to test the 0th element and the first element, but if you have 3 or more, you could as well use for lists or any other collection or any other iterable, assert iterable equals. Alright, so it's a common case which uses assert equals. This is a special case which uses assert equals. This is a special case that uses assert equals. This is a special case which uses assert equals. This is a special case which uses assert throws. Now in this, there is a slight naming ambiguity in our naming convention for unit tests, and I urge you to read or to view the appropriate appendix in order to get up to speed on the naming conventions we're using. I urge you also to adopt this naming convention or to work out your own naming convention for the naming of your unit tests. Here we have some null values that we're passing in. So this could be a special case, a nullable case, or because it throws an exception, an exceptional case. It's up to you. In this case, it's a special case because there is a value that's not null. But there is some leeway in the naming convention. in regards to special, exceptional, or nullable sometimes. So it's a special case that uses assert throws. This is an exceptional case that uses assert throws. And this is an exceptional case that uses assert throws. Let's run it to see that everything's okay. And here, not everything is okay. So, and I leave it up to you to decide whether it was planned or not. Actually, the very first time I recorded this clip, it was not planned, but then I decided to make it a kind of a planned event. Let us see what could be wrong. Here we have an assert equals that we're saying expected value is 0 and a result get is a list of doubles. So why is it not passing? It is not passing because we're using a wrong overload. We should be using an overload that basically expects a double, not a long or an integer. Let's go to the next one. Let's do 2.0 minus 2.0. And let's do this 0.0, 2.0 here. Let's double check this one that we did everything correctly. Okay. So let's rerun it. This brings a very interesting topic. We're using assert equals as if there is no tomorrow and other assertion methods. However, in the later part of the lecture, we're going to look at the overloads of the assert equals, assert throws, etc., etc. And there are plenty and plenty of overloads, and I urge you to study the appropriate appendix for the full API of the assertions class. And the assumptions class. It's called the API for the brave for a good reason. So let's rerun it again. Let's see if it works correctly. Now that we fix the code to call the correct overload, and it does. Okay, let's go on to the next one, to the hypotenuse unit tests. It tests maths.hypotenuse method, and there are seven unit tests. The first one is a common case, and it uses assert equals. The second one is a special case, and it uses assert throws. Could be an exceptional case as well. Third one is a special case, and it uses assert throws. Could be an exceptional case. The fourth one is a special case. It uses assert throws. Could be an exceptional case as well. The fifth one is a special case. It uses assert throws, and again could be an exceptional case. The sixth one is an exceptional case, uses assert throws, and the seventh and last one is an exceptional case, and it uses assert throws. So let's see that our hypotenuse tests run okay, that we don't have an overload issue here, and we don't. And lastly, let's check out that all the unit tests of the maths tests test class perform correctly. All 77 of them run just fine. And the last order of business, we need to run all the unit tests that we have written so far. And let's see how many we have. Alright, so far we have written 130 unit tests. They all perform correctly, they all run fine, and we're in good shape. The next test class we're going to explore is called collections tests. So see you in the next clip. JUnit Basic Assertions Lab 1 Rehash 2. So far in Lab 1 we have covered the following assertions since our first rehash. Assert timeout, assert timeout preemptively, assert all. So our next test class is going to be called collections tests. And first order of business, let us right click on the test package name, select new, select Java class. Type in collections tests and click enter. Then select what's inside this class, highlight it and delete it. Now let us go to the courses website, go to unit test code, collections tests, lab 1, go to the right upper corner of the code box, click copy, go back to the IntelliJ IDE, click Ctrl V. Alright. So we can see that within this collections class, collections tests test class, which tests our collections class, which is right here, are several nested inner classes. Is empty tests, is not empty tests, has nulls at tests, has nulls tests, has nulls count tests, max tests, min tests, peaks tests, and throws tests. So every nested class basically unit tests one method of the corresponding collections class. Alright. So in the next clip, we are going to proceed with the is empty tests array of unit tests. In this clip, we are going to run through the collections tests test class, starting with is empty tests nested class. So in collections tests and the following arrays test classes, we are not going to see any new assertions classes. However, I must give this code for completeness, because in addition to learning, what we're striving for is basically completing the testing of a kind of standalone utility library. So our testing must be comprehensive and it must be complete. Hence, even though we don't get any new material in these test classes, they still must be there in order to produce the completeness that we need. Alright, so isEmptyTests contains 5 unit tests, and it tests collections.isEmpty method. So the first one is a common case and it uses assert equals. The second one is a common case, it uses assert equals. The third is a special case, it uses assert equals. We just use a list of empty strings. The fourth one is a special case, it uses an array, a list of nulls. And the fifth one is a nullable case that uses assert throws and throws collections exception. So if at any point you would like to spend more time on this code, write this code out by hand, write out parts of the code, for example, the assertions method. Feel free to either pause the narration, during the clip, or feel free to get to the source code after the clip is completed, whatever you prefer. So next is our nested class is not empty tests, and it has 5 unit tests and it tests collections that is not empty method. The first one is a common case and it uses assert equals. The second one is a common case. It uses an assert equals. The next one is a special case. It uses assert equals. The fourth one is a special case. It uses assert equals. And the fifth one is a nullable case, and it uses assert throws. Next, we are going to go to the nested class has nulls at tests. And this basically just tests that our collection has a null at some point within the sequence of the collection. It has 4 unit tests. The first one is a common case, and it uses assert equals. The second one is a common case. It uses assert equals. The third one is a nullable case. It uses assert throws. And, well, here's what I'm going to do. I wrote the utility library so that it does not return any nulls from the methods. For example, if it would normally return a null, it returns an empty list or an empty set, etc., or it throws an exception. So basically, I've been meaning to test the assert null assertion method, but there is no proper way to kind of use it within the testing of the utility library. So I'm going to give a very contrived example and just use it like that here. That way I can say, well, I used the assert null method, I showed you how to use it, even though it's a contrived example and makes no sense. Overall, it doesn't add anything to the unit test, but it demonstrates how to use the assert null method. All right, let's see. Let's go on. This is a nullable case. It uses assert null and assert throws. The next one is a special case, and it uses assert equals. All right, let's go has nulls tests. And it basically says that a collection has nulls at any point of its sequence. This has nulls at certain indexes. This has nulls anywhere. All right, the first unit test is a common case, and it uses assert equals. The second unit test is a common case. It uses assert equals. The third one is a special unit test, and it uses assert equals. The fourth one is a nullable unit case and unit test, and it uses assert throws. The next one, the next nested inner class is has nulls count test, and as the name implies, it tests collections that has nulls count method. So the first unit test is a common case, and it uses assert equals. The second unit test is a common case, and it uses assert equals. The third one is a nullable case, and it uses assert throws. The fourth one is a special case, and it uses assert equals. And once again, if you need more time to study this, or if you'd like to make any kind of tactile changes to the code to exercise your motor memory, feel free to pause the presentation at any point or at the end of the presentation, etc. Feel free to take as much time as you need. This is your course. You decide how you best learn. All right. The next inner class is going to be max tests. And as the name implies, it tests collections that max method, which is kind of self-explanatory. The first unit test is a common case, and it uses assert true. This I did so that we use some more assert true assertion method. We could use assert equals. Because we haven't seen a lot of assert true, I'm going to retype it a couple of times. All right, let's see. but it is a good substitute for assert equals, even though assert equals is a better fit due to the fact that you don't have to write as much code within the method. The next unit test is the nullable case, and it uses assert throws. The third unit test is a special case, and it uses assert throws. The fourth is a special case, and it uses assert throws. And the fifth is a special case, and it uses assert true. And here I'm going to write again, to rewrite assert true again. And we are good to go. The next set of unit tests is the inner class min tests, testing the collections.min method. The first unit test is a common case, it uses assert true. I'm going to stop retyping it. You're welcome to retype it if you want. The second unit test is the nullable case, it uses assert throws. The third unit test is a special case, it uses assert throws. The fourth is a special unit test, is a special case, it uses assert throws. And the fifth is a special unit test case, and it uses assert true. Alright, we're getting towards the end of this test class. There are two methods that remain to be tested. The next inner class is pix tests, and it tests the corresponding method collections.pix, which finds a list of pix within a sequence of collection values. The first unit test is a common case, it uses assert true, and we use it twice. First to ascertain the size of the returned result list, and second is to get the first value. The next unit test is a nullable case, and it uses assert throws. The third unit test is a special case, and it uses assert throws. We've been using assert throws a lot, just because our utility library has a very well defined rule of when it throws exceptions. The fourth one is a special case, and it uses assert throws. The fifth and last one is a special case, and it uses two assert true assertion methods. Alright, last but not least is the throws test, pardon my pronunciation, and it tests collections.throws method, which returns a list of lowest values within a sequence of collection values. Alright, the first unit test is a common case, and it uses assert true. The second unit test is a nullable case, and it uses assert throws. The third is a special case, and it uses assert throws. The fourth unit test is a special case, and it uses assert throws. And the fifth one is a special case, and it uses assert true. Alright, we have completed reviewing the unit tests within the collections tests. Let us now run all the collections tests to see that everything runs fine. We have to wait for end to build. Alright, and all the 42 unit tests of the collections tests test class run correctly. Now, last order of business is for us to run all the unit tests we have written so far. All right, there should be more than 200 at this point. It's actually, we have 172 unit tests at this point. All right, wonderful. And in total, we are having about 220, I would say, unit tests. So, all right, this completes this clip. In the next clip, we're going to do the fifth and last test class arrays tests. So lastly, and the fifth test class we're going to do is going to be arrays tests. So please right click on the tests package, select new Java class, type in arrays tests. Then delete everything within the class that's automatically generated. Go to the courses website, go to unit test code, arrays test Java, lab 1, click on copy, and press Ctrl V. Alright, so within arrays test we're going to have identical nested inner classes to the collections tests, except instead of collections we're testing arrays. It's going to be isEmpty tests, isNotEmpty tests, has nulls add tests, has nulls tests, has nulls count tests, max tests, min tests, peaks tests, and throws tests. Alright, so in the next clip, we are going to run through the unit tests embedded within the inner classes. And at the end of the clip, we will have covered all the 5 test classes and more than 200 tests. Then, in the clips that follow, we will cover some overloads of the assertion methods. And at that point, we will have been done with lab 1. So please stay sharp and focused. We're almost done. So we're going to explore the fifth and last unit test class called arrays tests. And we use it to test the arrays class of our utility library. So let's start on the arrays test class. Let's start with the nested inner classes empty tests that tests out arrays that is empty method of the arrays class. And, because arrays is a very prominent class of the JDK, here we're using the fully qualified class name. Alright, the first unit test is a common case, it uses assert equals. The second unit test is a common case, it uses assert equals. The third unit test is a special case, it uses assert equals. The fourth unit test is a special case, it uses assert equals. And the fifth one is a nullable case and it uses assert throws, because every time we get a null value passed in, the rule of our utility library is we throw an exception. Alright, let's go to the isNotEmpty tests inner class that tests arrays that isNotEmpty method. The first unit test is a common case, it uses assert equals. The second unit test is a common case, it uses assert equals. The third unit test is a special case, it uses assert equals. It's actually, looking at this second one, we are using a zero length array. So we could call it a common case or we could call it a special case. It's up to us. It's a little bit hazy at this junctures when we have these cases. Alright, so the third one is a special case and it uses assert equals. The fourth one is a special case and it uses assert equals. The fifth one is a nullable case and it uses assert throws. Let's go on to the has nulls at tests. It takes basically our array and it returns the indexes at which it has null values. Alright, so the first unit test is a common case and it uses assert equals. The second one is a common case, it uses assert equals. The third one is a nullable case, it uses assert throws. And the fourth one is a special case and it uses assert equals. Right, next on the list is the has nulls tests inner class, which tests arrays that has nulls, and it basically returns a boolean when our array has at least one null value in its sequence. The first unit test is a common case and it uses assert equals. The second unit test is a common case and it uses assert equals. The third unit test is a special case and it uses assert equals. And the fourth one is a nullable case and it uses assert throws. The next one is has nulls count tests and it tests arrays that has nulls count. It basically tests the number of times an array sequence has null values, or rather null elements. The first unit test is a common case, it uses assert equals. The second unit test is a common case, it uses assert equals. The third unit test is a nullable case, it uses assert throws. And the fourth is a special case and it uses assert equals. And once again, at any point of the narration, please feel free to basically stop or pause, write any code you feel you need to write to get the most out of a particular unit test, either during the course of a video clip or at the end. It is up to you. So the next inner class is max tests, and it tests arrays.max method, which just basically finds the max value within an array sequence. And the first unit test is a common case and it uses assert true, although we could better use assert equals, less code for us. The second one is a nullable case, it uses assert throws. The third one is a special case, it uses assert throws. The fourth one is a special case, it uses assert throws. And the fifth one is a special case and it uses assert true or assert equals. Alright. The next inner class is min tests and it tests arrays.min method. The first unit test is a common case and it utilizes assert true. The second unit test is a nullable case and it utilizes assert throws. The third unit test is a special case and it utilizes assert throws. The fourth unit test is a special case and it utilizes assert throws. And the fifth is a special case as well and it utilizes assert true. Although assert true and assert equals are interchangeable, and usually assert equals results in less typing. Alright, the next one is the picks tests, and it tests the arrays.picks method, which returns a list of basically maximal values, so picks within an array sequence. The first unit test is a common case and it uses assert true a couple of times. The second unit test is a nullable case and it uses assert throws. The third unit test is a special case and it uses assert throws. The fourth one is a special case and it uses assert throws. And the fifth one is also a special case and it uses assert true a couple of times. And also please notice that we always use a try catch construct, and we use another assertion method that has kind of flown under the radar until now. It's the fail method. Whenever the JUnit runtime sees the fail method, it just fails the test. So whatever exception may be thrown, it will, that we failed to, for some reason, catch, it will cause a failure of the test, of the unit test. And you can also see that we used sometimes fail with empty parameter list and sometimes fail with a string parameter, because the fail method is also somewhat overloaded. All right, let's go to the last one. It's a throws tests, and it tests arrays.throws method, which returns a list of minimal values in an array sequence. All right, the first unit test is a common case, and it uses assert true. The second unit test is a nullable case, and it uses assert throws. The third unit test is a special case, and it uses assert throws. The fourth unit test is a special case, and it uses assert throws. So it passes in an empty array. Remember, it could be a special case or a common case. Preferably, of course, it is to be named as a special case. Okay, and last on our regimen today is a special case, and it uses assert true a couple of times. All right, let us now see that all the arrays tests pass. And if my memory serves me right, there should be around 42 of them. Alright, and all 42 of them pass with flying colors. What we're going to do as the last order of business, we're interested in running all the unit tests in all the test classes. And that's what we're going to do right now. Alright, just waiting. Alright, wonderful. It took about 2 seconds, and we ran 214 unit tests, comprehensively testing our utility library. Great job. Thank you for keeping with me. There are a couple of clips to follow, an overview of what we've covered since the last rehash, and also I'm going to give an example of certain overloads that are available within the Assertions class API. So thank you for your attention. Stay tuned. See you soon. JUnit Basic Assertions Lab 1 Rehash 3. So far in Lab 1 we have covered the following assertions since our second rehash: assert null and fail. Basically this concludes our coverage of assertions. And the next clip, we are going to focus on certain overloads of the assertion methods we have already covered. So basically, let us return to the object's tests test class, and we're going to explore basically two types of overloads that nearly every assertion method has. One of those overloads deals with the fact, and we'll start with the more complex one. We're going to go actually to docs.oracle.com to Java Standard Edition version 14, version 14.0.2 to be precise, and we're going to look for the supplier functional interface, which is found in the module java.base and package java.util.function. So a functional interface is an interface that can be implemented as an anonymous interface by implementing its get method, or it can be substituted with a lambda. And the lambda is the preferred method of doing so. And basically, nearly every method of the assertions class provides a list of its arguments, and then as the last argument, it provides a supplier type T interface. And the good thing about the supplier type T interface, which we can use as a lambda or as a method reference, is that we can substitute or place some variables within it that have to be, however, final or effectively final. Well, effectively final means that we can declare a variable. We don't declare it final, we just don't initialize it. And then based on some parameters, we can basically set the value to the method. And the value can be different based on certain conditions. We can set the value only once within the flow of logic. That is what it means to be effectively final. Basically, we initialize a non-final local variable. We declare a non-final local variable. We don't initialize it. And then we write some kind of condition or pass it to some kind of method that returns this or assign the value of some method to it. But we can do so only once and only once through all the flow of logic through the method. And then we can use this variable, which the compiler deems effectively final, as part of our lambda. That way we can basically pass different values into the lambda based on our logic. And we can tailor those values to actually the outcome of our assertion method. So in this case, for example, the object is not null, and so object that is null value is false. And we are asserting that it is equal to false. So the assert equals method will pass, and the result of this lambda will not be placed into the log as a message of why the method failed. Let us see how it works. Let's run this method. So if the assertion method passes, this lambda is ignored. Right, we can see that the test runs, and in the log there is quite nothing. However, should we make it so that the method fails, we will see our message with the appropriate value of the I string variable. Let us see. The unit test will fail, and the log should give us a nice message of why it failed. Equals assertion has failed, and here is our variable, the I variable. It says object is not null. All right. Okay, so that is how the supplier type T interface works, and it is overloaded as the last parameter on virtually every method of the assertions class. Right, let's change it again to false so that it doesn't come up anymore. And let us go to the simpler overload. Pretty much every assertion method of the assertion class is also overloaded in the following manner. The list of arguments is first, and in the last place, except of supplier type T, there is just a string. And that string is a static string, and that string is shown in the log if the unit test fails. So right now it will not fail. Let's see what will be in the log. Alright, and there is nothing in the log. And now let us make it so that the test fails. Alright, so we get the assertion failed error, the object is null in the case. So that is how it works. If we wanted to do it so that we could also have some dynamism here, we could also do this. And in this case, there is no requirement for it to be final or effectively final. So let's see how it will work. Alright, the object is null, column object is null. So that is how we use the string that contains some variables that we make part of the string. So what is the betterment of using supplier of type T just to a string? Well, when you're using supplier of type T, you're essentially not constrained to just concatenating strings. You can run some code. You can use some logic within the lambda, etc. So, for example, we could do this. Already. We could use the fact that our object O is a effectively final variable, and we could move all the logic of figuring out what the string should be within the lambda, effectively hiding it from our code. And if we use a method reference, we could just completely hide it. Alright, so I'm giving you very simple examples that hopefully demonstrate the power of the supplier type T functional interface as applies to the overloads of assertion methods. Right, let's see. When it's true, it does nothing. I mean, when it's false, it does nothing. Let's now make it fail, and let's see what happens. Remember, all of our logic of what the complete message string should be has been moved into the lambda. Alright, so equals assertion has failed, object is not null. So this completes our study of the two most common types of overloads. The first one is the usual list of parameters of an assertion method, followed and completed by a supplier type T functional interface. And the second common overload is the assertion method with its customary parameters, and in the last place, string, which is a message that is displayed if the test fails. And also for the supplier type T, the functional interface is run only if the test fails. So this completes lab 1. It's been a very arduous lab. It is probably the most arduous lab of the 7 labs that you're going to pass. And of course, thank you for sticking with this lab. Labs 2 and 3 are going to be fairly short and simple. Lab number 4 will be quite complex, probably the most complex in terms of time and involvement lab of the course. And labs 5 is going to be simple, and labs 6 and 7 are going to be complex, but not as involved or arduous. So congratulations. I would say you're about 30% done with the hardship of the labs. So I'll see you in lecture